Question number 111. A. Amphibians of the plant kingdom. B. Gametophyte is monoecious and free-living, but the sporophyte is partially dependent on the gametophyte. C. Sporophyte is well differentiated into foot, seta, and capsule. The above features A to C are associated with first option Rixia, second Machinchia, third Funaria, and fourth Selaginella. So you have to read these features which are given over here and then find out the organism to which these features belong. Here you have to put more emphasis on this B statement where it says that sporophyte is dependent on the gametophyte. In case of bryophytes only, the sporophyte is dependent on the gametophyte. In rest other plant groups such as pteridophytes, gymnosperms and angiosperms, the sporophyte is the main plant body and it is not dependent on the gametophyte. So for sure we are talking about the bryophytes. So bryophytes has been divided into two groups, that is liverworts and the mosses over here. Again, this statement that sporophyte is partially dependent on the gametophyte. So in bryophytes, the sporophyte is dependent, but it is partially dependent, which happens in mosses. In case of mosses, the sporophyte is partially dependent, but in liverworts, it is completely dependent on gametophyte. So it's a moss, not the liverwort. Sporophyte is well differentiated into foot, seta, and capsule. Yes, it can happen in both liverworts as well as mosses. Amphibians of the plant kingdom is true for both liverworts and mosses. But the B statement, the B features is just related to the mosses, not the liverworts. Markentia, it's a liverwort, so this option is ruled out. Rixia, it's a liverwort, so this option is also ruled out. Selaginella is a pteridophyte where the main plant body is the sporophyte, not the gametophyte, hence this option is also ruled out. Funaria is a moss in which sporophyte is partially dependent on the gametophyte. So the correct option for the given question is option number 3. Let's see another question. Question number 112. A creeping green branched and frequently filamentous structure that arises from spore in bryophytes is called first option gamma, second protonema, third bud, and fourth sporophyte. If you see the life cycle of mosses, you will find that they have main plant body which is gametophyte, which bears male and the female 6 organs, and they produce male and female gamete respectively. These gametes fuse together to form zygote. This zygote undergoes mitosis to form embryo. Embryo forms the plant body, the diploid plant body, which is called sporophyte. Sporophyte is differentiated into foot, seta, and capsule, and this capsule of the sporophyte has spores. These spores on liberation germinate and they produce a structure called protonema. So protonema is the creeping filamentous green gametophytic structure. Protonema forms the leafy gametophyte or the adult gametophyte. So it's a life cycle of mosses. So see the first option gamma, no. We have discussed in one of the previous questions that gamma is the multicellular asexual bud which helps in asexual reproduction in liverworts. It is not the filamentous structure. So this option is ruled out. Third one is bud, no. Again it helps in asexual reproduction. Fourth is sporophyte. Sporophyte is the plant body, the diploid plant body. This is not the filamentous structure. This option is also ruled out. So the correct option for the given question is option number 2. Let's move on to the next question. Question number 113. Antherozoids of bryophytes are first multiflagellated, second multiciliated, third biflagellated, fourth non-motile. This is very easy question. I guess this is the easiest question from your paper, that bryophytes have enterozoids and these enterozoids are motile and biflagellated. So the correct option for the given question is option number 3. Let's move on to the next question. Question number 114. Chlorophyll A, C, carotenoids and xanthophylls are found as major pigments in all except first option laminaria, second dictyota, third porphyra, fourth is fucus. These pigments, chlorophyll A and C, carotenoids and xanthophylls, are found in all of the given organisms except, so these are the pigments which are found in brown algae. So first you find the brown algae, dictyota, yes, fucus, yes, laminaria, yes. These all are brown algae and they have these all the pigments. What about the porphyra? Porphyra is a red alga. Hence, it does not have chlorophyll C. Instead, it has chlorophyll D. So the correct option for the given question is option number 3. Let's move on to the next question. Question number 115. Hydrocolloid carrageen is found in the cell wall of first option Phaeophyceae, second Rhodophyceae, third Chlorophyceae, fourth Cyanophyceae. Chlorophyceae, these are green algae and they do not have hydrocolloids. So they do not produce hydrocolloids. Cyanophyceae, they are blue-green algae or bacteria. They are not true algae, they are bacteria. They also do not produce any kind of hydrocolloid. So this option is also ruled out. What about the Phaeophyceae? Phaeophyceae are the brown algae and they produce a hydrocolloid. But it is algin, not the carrageen. So this option is also ruled out. Second option, Rhodophyceae. These are red algae and they produce a hydrocolloid called carrageen. So the correct option for the given question is option number 2. Let's move on to the next question.